Alright, last binomial expansion video. Um, going to be looking at a little bit more partial fractions in this one. So, get straight into it. Exam question, typical exam question from the old spec here. So, first part, split this into partial fractions. So 3x minus 1 minus 2x squared. It's worth noting with this particular question, we actually could just do a binomial expansion on this straight away by writing it in this format. Do the expansion on this bracket and then multiply by 3x minus 1. That's fine. But they've asked you to do it a bit differently in this question. And you can see in part B, it actually says hence or otherwise. So first part, partial fractions. I'm going to let you guys do this bit. So it tells us 3x minus 1 over 1 minus 2x squared is a over 1 minus 2x plus b over 1 minus 2x squared. So it's a repeated root, remember, so we have to write it the non-squared and the squared version, because both of these are factors of 1 minus 2x squared. So I'm going to pause it here, and you guys can figure out where A and B are. So here's your answers. A is minus 3 over 2, B is minus a half. It doesn't actually tell you to write out in partial fractions, it just says what's A and B. Just a reminder that if you do get A or B being fractional, you'd write it out like this. So numerator, denominator, numerator, denominator, like so. Alright, so I'm going to rewrite this again, and I'm going to write it as minus 3 over 2, 1 minus 2x to the minus 1, minus a half, 1 minus 2x to the minus 2. So you can see this fraction is here and this fraction is here. So don't forget, if you apply the law of indices that 1 over a certain power is just that power negative, then you don't bring up any coefficients in the denominator as well. Okay, so this is a half times 1 over 1 minus 2x squared. This 2, the 2 in the half here, that is not to the power of 2 like the rest of the bracket is. So this would be like this. This is like a little fiddly bit of algebra, not necessarily actually part of this topic. And it's asked us in the question to do series expansion of f of x up to x cubed. So I could, because it says hence or otherwise, I could actually just go back to the original question and write it out like I said up here, and then just do expansion on minus this 1 minus 2x to the power of minus 2 and multiply by 3x minus 1. That actually probably be slightly quicker than doing it this way, to be honest. But what I'm going to do is I'm going to do each of these separately. So I'm going to highlight this in green, and we're going to essentially just kind of do two different questions over here, two different expansions, and then we're just going to put them back in to get our answer. So this is the first expansion I'm going to do, is the first bracket here, 1 minus 2x to the power of minus 1. So if I just copy over our formula here, so if I'm doing 1 minus 2x to the power of minus 1, following the formula, it's going to be like this. Always put the things you do here in brackets, do exactly like I do, because it just makes it far less likely for you to make a mistake. This is going to be kind of annoying actually, because it's asked us to go up to cubed. That's supposed to be a squared, because I said cubed halfway through. I started half writing at 3. It's asked us to go to cubed in the expansion, which honestly just feels like it's a bit of a waste of time. It's basically just checking like how patient you can be and putting stuff in your calculator and things like that. So this one would be minus 1, minus 1, minus 1, minus 1, minus 2 over 1 times 2 times 3 minus 2x cubed plus dot dot dot. So we have to simplify this now. simplifying these, actually not too difficult because you'll notice the numerator actually just cancels in the third and fourth term. This is just 1 times 2, and this is also 1 times 2. So this is just going to cancel and give us 4x squared. And there's actually a similar thing going on with this one. This is 1 minus 1 times minus 2, so the next term, minus 1 times minus 2 times minus 3 over 1 times 2 times 3. So it's just minus over plus, but it's the same numerical value. So it's just going to be minus 1, but it's actually going to end up being plus 8x cubed plus dot dot dot. Okay, so that's our first bracket. Maybe not quite as tedious as I expected it to be. Hopefully it won't be so bad in the second one either. So I'll do this in a different colour now. We're going to do this separately over here as well, so we'll do it in a nice pink. 1 minus 2x to the minus 2. So here we go. 1 plus, so nx minus 2 times minus 2x. Looks like it's going to be a pretty similar outcome to what we had before. So let's just give ourselves a bit more space over here. So minus 1, minus 1. So it's minus 2 because n is minus 2. Minus 2 minus 1 minus 2x squared over 1 times 2. And then minus 2 minus 2 minus 1 minus 2 minus 2 over 1 times 2 times 3 minus 2x cubed plus dot dot dot. And then we simplify. 1, so it's going to be plus 4x. So minus 2 times minus 3 is 6 divided by 2 is 3. 3 times 4x squared is going to be 12x squared. And then we can do the same thing here. So 2 times by 3 times by 4. So it's going to be minus 24 in the numerator divided by 6 in the denominator. Minus 24 divided by 6. What's that? Minus 4 times by minus 8. So just 4 times 8. 32x cubed. I know you haven't pressed play on this video just to watch me do mental arithmetic, but here we are. Quickly check that that's correct, just so we're not wasting time. Yes. Okay, so let's groove back to the question. So here's what we had. Wait a minute. This is slightly incorrect. This should be positive. Yeah, B should be plus a half. There we go. Oh, that's going to be annoying. I'm going to have to go back and put a comment on. Whatever. So, I can't be doing re-recording the whole thing now. Right, minus 3 over 2. Mistakes. So anyway, we did this bracket as a green expansion over here. So it's 1 plus 2x plus 4x squared plus 8x cubed. And then plus dot dot dot, but whatever. And then the pink bracket is going to be a half times by the expansion we had down here, which is 1 plus 4x plus 12x squared plus 32x cubed plus dot dot dot. So I mean we can just simplify it here, and when we do that we will get 1. So expand the bracket. I'm not going to do that, you guys can do basic algebra yourselves. This would be the outcome up up to the x cubed term. Do note, it says x cubed term. If it said like up to the fourth term, we'd actually have to go another term, even though the x squared would normally be the third and the x cubed would normally be the fourth. In this case, the x cubed is actually the third term, so just read the question carefully. Anyway, that's the answer. There. So essentially what I'm saying is, it is nothing new. Do each fraction like a separate question and then put it back together at the end. So here we go, nice zoom out, see the whole working out. Did each fraction as a separate question and then put it back together and got the final answer there. So, one more. There's a partial fractions question here as well. Part A, pause the video, do it yourselves. I'm not going to do partial fractions for you. You can work those out. There you go. A is 0, B is 4, C is 3. You need to be able to do that. That is going to come up in the test that we do like the week after half term. Hence or otherwise, do the series expansion. So here we are again. Let's write this in a way that we would write it if we did a series expansion. So it's a little bit nicer than the first one because there's no annoying fractions. So there's no numbers in the denominator that we might accidentally bring up to the top or anything like that. So here it is. This is what we're going to expand. So once again, let's do a couple of different colours. So we're doing this bit here. We'll do an expansion for this. So I'm going to do it over here. So 3x plus 2 to the minus 2. So do be careful in these questions. They write them out in a way that is not necessarily friendly to expand in the first place. So let's go and have a look at our formula from the formula book here. So the formula wants it to be 1 plus x to the power of n. So we know that we probably want to factorise the 2, but what we also want to remember to do is actually just go ahead and write this in a different order before we do anything else, because otherwise we might do something stupid. So we'll factorise out 2 to the minus 2, so we get 1 plus 3 over 2x to the minus 2 like this. And then we can just go from here. So 2 to the minus 2 is 1 over 4. We'll worry about that afterwards, putting it back in. And we'll just go ahead and do the expansion. We're going up to x squared here, so not as far as before, thank God. So going to be a bit quicker. 1 plus nx, so minus 2 times 3 over 2x plus n times n minus 1 over 1 times 2 x squared. So remember, x is actually 3 over 2x in this case. The x from the formula, that is. So quarter 1, so this is going to be minus 3x. What's this going to be? So 6 over 2 is 3. 9 times 3 is 27. So is it 27 over 4? X squared, is that right? Yeah. Positive, yeah. Positive 27 over 4x squared. Plus dot 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 should be in there as well, but it's not too important for getting all the marks and such like that. Right, so that's the first bit done. It's quite nice actually, if you notice, because this is 4 and then this gave us a quarter, so when we put this back in, it's actually going to cancel away and give us something quite nice and tidy. Great news. Alright, next bracket, this one, 1 minus x to the minus 1. It's going to be much easier because it's already written in the way we want. So 1 nx minus 1 times minus x minus 1 minus 1 minus 1, oops, 1 times 2 squared 2 over 2. Just take, yeah, it's just saying it. There we go. Let's do the question. So we've done the expanding bit. So 2 separate questions. We kind of do it separately over here. Might find that I need a little bit more space for this. So let's shrink these down and just move them to one side. So as I said, if we put the green one back in, it's going to be 4 times a quarter, so we can actually just ignore the 4 and the quarter, or if they can't ignore them, they cancel each other away. They aren't there anymore. So we get this, and then 3 times 1 plus the pink, 3 times the pink expansion. I should be saying, what am I doing here? I'm just writing nonsense. And then we expand the second bracket and simplify it. It's gonna The x's are gonna cancel, so we're gonna get 4 plus 39 over 4x squared. Bob's your uncle. Last question. I don't think we've quite seen one like this yet. Find the percentage error made in using this series expansion. So here, this series expansion that we got, we want to find the percentage error for calculating the value f of 0.2. So essentially what we're doing is, because we've made a function which estimates the original function, because look at this original function, we might want to do something with that, like integrate or differentiate it or something, okay? But that looks like it's quite hard to do. But if I make an approximation, hey look, this is much easier to integrate or differentiate. Awesome. We're not doing that though, we're just going to sub in some random numbers, as long as the numbers are less than 2 over 3. So the number we've been asked to sub in is 0.2. So we're going to find out what f of 0.2 is. So f of 0.2, I should say as well, because this is where we did the approximation. This should be like this, because that's like an approximate thingamabob. So, I suppose I could, if I put plus dot 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 at the end, it would be equal, whatever. So, anyway, f of 0.2, put 0.2 into the original function. So I could either do that in what they give me in the question, might be more sensible because maybe we got the other bit wrong, to make sure we get all the marks. I mean, I don't think that matters too much though, because you get error carry forward marks, but let's do 4 over 3 times 0.2. Let's just do it in the one we had here, plus 2 squared, plus 3 over 1 minus 0.2, like that. Put it in your calculator. There we go. It's me pretending to use a calculator because I've already got the answer in here, because I knew I wouldn't be bothered to do this on time. So it is 2,935 over 676. Or you could have it as a decimal, which is like 4.3-ish, but they want to see like clear evidence that you put it into the original function. So I'm going to make a note here as well. This is from the original. So we also want to do f of 0.2 from the estimate. So the estimate for f of 0.2 is in the function that we approximated from our original one. So it's going to be this, which is 4.39 exactly, I think. This is about, the first one's about 4.3 as well. So I'm just going to make a note, even though I already wrote it in black, I'm going to write it here, estimate. So it says calculate the percentage error. So percentage error, you probably see it in science, things like that, but this is something people always seem to forget how to do this. Percentage error is just the difference between the two the original and the estimate as a percentage of the original amount. So like how far is the estimate? What percentage away is the estimate from the original? So it's going to be original minus estimate over original times 100. And people often ask, which way around does it go in the top? It doesn't matter, because you're just going to say it's positive no matter which one you do. Okay? So just find the difference between the two, say it's a positive number, and then go from there. So we're going to be doing 2935 over 676 minus the estimate, which is 4.39, divided by the original, which is this again, times 100. And that, if I put it in my calculator, is about 1.1% error. So it's pretty close. So you see questions like this a lot, and people do lose marks on them because inexplicably people just forget what a percentage error is, even though just from its name I feel like it's kind of obvious what it should be that you're calculating there. It's just the percentage error from what the original amount was. There's some questions like this in the textbook if you want to practice more. And speaking of the textbook, last exercise in this chapter, exercise 4C. So that's what you need to be getting on with now. And a mixed exercise, of course, as well. So get cracking on all that stuff, and I will be in contact with you again after half term. I can't remember what we're doing. I think it's going to be radians after half term. We're going to get onto radians anyway, and we'll have that test that we're going to do, which is going to be on binomial expansion, but it will have partial fractions questions in it as well. I'll be setting you some more half term homework to do also, which will be due in after half term. I want to see photos of that. Have a nice half term. Don't work too hard. Don't stress yourselves out too much, but make sure you do work hard enough. Goodbye.